Hi everyone, today I'll be teaching you how to make this system in TouchDesigner using the new pop operators that were just introduced in the latest experimental build. Because this is experimental still, depending on when you're watching this, some things may be a little different, like some parameters may have moved around, but the overall process and the overall technique I'll show today should be the same. I'm working on build 30060. What we are going to be doing today is this system of trail tubes, and we are going to make two versions of this. One that, as you can see, the faces are flat, and you can see what's going on here is that it's a bunch of colliding circles. We're also going to make that in pops, and this other one that works better with twisting motions, and we'll see why we have two different ones in a second. So we can start. First, I'm gonna delete everything, and let's start as always with a constant that has our parameters, which in this case just gonna have the number of circles we want and their divisions, because circles aren't circles here, they're actually just polygons with high divisions, and also the length of all our trail length, and let's keep that like 20 times 20 and 100. Okay, now let's set up a null that we're just gonna call data, and we can start with a circle pop. Let's change it to surface. I'm gonna sprinkle our points into that on top of that surface. We can use here our first parameter for a number of circles. There we have 20 different points, and well, as you can see, this is pretty similar to how you would do it in subs, but I think one of the most useful and cool parts about pops is that you can use attributes to do all sorts of things. So now we're gonna create an attribute using the attribute pop that is gonna keep the value of our radiuses for each circle, right? Because this is just points, and we want to actually make circles with specific sizes. So I'm gonna make a new attribute called radius, and it's gonna be a float, and for now let's just keep it at like 0.1. And actually, if I get another circle and I'm gonna have it be the same divisions as our parameters over here, I can copy this circle onto those points and use that radius attribute that is being created within this pop to change the scale of each circle. I can use the template tab over here and then change the scale to use our radius, and there it is. They're all the same size, and to change that we can actually use a noise here that instead of outputting the noise, I'm gonna multiply our radius, and since while we're multiplying we need to change the offset to 1, and if I increase the amplitude, you can see now we get circles with all sorts of different sizes, and that's good. So now that we have this, we need to make it so that these circles don't overlap each other. So in order to do that, I'm gonna use a feedback and GLSL. So first, let's get our feedback, and I'm gonna use a GLSL pop, and let's just add a null here to finish their feedback loop, and I'm also gonna add a keyboard in to reset this. And this might look familiar, right, if you've worked with feedback in TOPS. But now we can use this same workflow to change geometry, which is really cool. There's no there isn't a feedback sub, right? Okay, so now we're gonna here in our computation do all of our collision detection, all of that. But first I'm gonna actually use the neighbor pop to pre-compute a lot of the things we're gonna use, so we don't have to compare every point against each other. We only have to check for the points that are closest, so we actually save a little bit of computation, right? So I'm gonna use this neighbor. I'm gonna this max distance will actually just be the biggest possible radius times 2, right? Because farther away than that we actually don't care about checking for neighbors, since those wouldn't be possible to those for those to be colliding. So I'm gonna take our base attribute here and multiply that with our amplitude of our noise. I'm gonna have this here just so I can copy, and now I can just multiply. Let me get more space over here, and I can multiply by 1 plus the amplitude, and there you go. And also I need to multiply all of that times 2. Alright, just like a tiny optimization there. And then when I output the neighbors and our max neighbors, it's going to depend on the amount of points you have. So you should vary this depending on the amount of collisions you expect. I'm gonna just keep it like a good 10. It's probably more than enough. Probably way more than enough actually. And we need all 3 of these attributes, and that's it. Now if we use a pop here, a pop to that, we can see the attributes that this generated. This distance and neighbor attributes, as you can see, they are actually arrays of length 10 instead of the usual attributes that you can see here. For example, our radius is just a single float, but these nerves are actually the neighbors, and the distance are whole arrays, and the length is set by our max neighbors, and then neighbor returns the index of the point, and the distance just gives you the distance, right? And I'm gonna use GLSL here because, as far as I can tell, right now there isn't a way for us to iterate or to loop through these arrays that this rainbow operator creates in only like non-code pops. So I don't know if in the future that will be added, but that's why I think we have to use GLSL for this still. But it is like it's still way, I think, like easier and cooler than what it was before. So also I need to, this distribution should be the closest, so this is sorted by closest. Okay, now we can go into our GLSL. I'm gonna edit, and here it is. Now here we have by default an example of like how to get points attributes, and you can see it's just this format tdin_p. I'm gonna save. I'm gonna play. You can see there's an error, and that's because we right now don't have any output attributes. We need to actually set it to p in order to be able to write to it. Now it works, and it's not doing anything because our code is just passing back the original point, right? But now let's start with our shader here. Now first of all, I'm gonna create a variable to keep the position of our point. I'm gonna make a vec2, even though, you know, points in here in this context are always 3D, but since we are doing collisions in a plane, we don't need that third dimension. So I'm gonna just say to pop, and I can even copy it from here and just get the X and Y. And I'm also going to do the same for our radius. Instead of doing a vec2 is a float, and the format is the same. It's td_in underscore and the name of our attribute, which in this case is just radius. And I'm also gonna get the number of neighbors that we have, so we know how far into our array we should iterate. Num neighbors, and that's saved in the attribute that our neighbor pop created, which is just called num neighbors. And let's see, now we can iterate. We can use a for to go through each point, and this should go up until the num of neighbors. And for each one of them, we should get the distance, which is already pre-computed through the neighbor pop. And this one will be a little different because now we're trying to get an attribute that is an array, so we need to actually use the parameters that are going here. You can see here in the example that you can take 2 parameters, but you can actually take 3. So the first one is always just the index of the input we're checking. Right now our GLSL only has 1 input connected, but you can connect as many as you want here. So that's what the first one points at. In this case, it's always going to be 0 because we only have 1. And then we have the index of the point whose attribute we want to read. In this case, just the same we're reading, the our current index of the current thread. And then at the end, because it is an array, you can pass down an index for you to sample, right? In this case, just going to be I, because our counter. Okay, that gives back our distance, and we need to also get the radius of our other neighbor for us to see if they're too close. And let's first get the index of that neighbor. Let's call it index, and that is saved in the neighbor, I don't know how to pronounce it, the neighbor attribute that our neighbor pop created. And again, it's like 0 td index is the same as our distance. And then you can do our radius, that is going to be checked from the radius's attribute, still at our input 0, but now instead of checking the index, I missed here the parentheses, instead of checking the current index, we actually check the neighbor's index, which we got right there. And now we can perform our check. So basically, if our 2 points are too close to each other, if the distance between them is less than the sum of the radiuses of the radii, that means that they are too close to each other and they should be pushed back. So if the distance is less than the radius plus the neighbor's radius, then we do our pushback, right? Now to get the pushback, I'm gonna need the position of our neighbor, and we can get that the same way we got the radius. And now remember here again, this is a position, so this is gonna be a vec3, but we actually only care about the first two components. And now we can keep track. Before 4, we need to check against every point that is close to us, so every neighbor, and then we're gonna add up all the transformations we need to get away from every single one of those. So we actually need to keep track of a sum, a vec2 sum, that will give us the final translation we need to perform. Let's just leave it like that, 0. And so here, if this is true, then we need to translate away from our neighbor. I'm going to do that. First, I'm going to normalize the difference of our position minus the neighbor. That will give us a direction vector away from the neighbor. And we need to, the length is just going to be the difference between the distance and the sum of the two radii. How much distance is left for the distance between the 2 points to be the same as their radiuses, right? So that will be, they're just kissing each other. And then I'm going to multiply that by 0.5. Okay, let me first do the radius plus the neighbor's radius minus the distance, and I multiply that by 0.5 because this is a translation made by our position in respect to the neighbor's position, but that neighbor in its own calculation is going to move away as well. So I'm going to multiply by 0.5 because they are both doing the push away. Okay, and that's it. And then at the end we can do just position plus equal the sum. That's it, and we pass it down instead of returning this. Well, I can get rid of all this. We say a vec3 because our position is a vec3, and then it's just pause, and for the set it's just 0. Let's save that and go back to touch, and we can see something is moving. Let's connect our copy to these new positions to see what's going on, and you can see it's working. If I reset it, it goes to full. Now when I increase this attribute, you can see they get really big and kind of start going everywhere. Maybe we don't want that, so I'm gonna restrict these points so that they're just inside of a circle. And to do that, I'm gonna at the end here, after our sum, I'm gonna just say pause for position is equal to, let's normalize it, and then multiply it by the minimum of the length of position and 1 minus the radius. And what that's going to do is going to restrict our position. Oh, there's an error, and oh, there's no this MP is pause, and we can see now they are just within this circle of radius 1. You can see this is jittering around, and that's because on one frame is pushing one way and the next frame is pushing another, so it is jittering. and we're gonna do that, something about that in a second. Then now you can see these points are restricted to this circle, and we should expose a parameter to change the radius of a circle so it's not hard-coded. So let's add here a vector that is just called bounding radius. It's going to be a float, and we can set it to 1 for now. And now in our GLSL shader, we can add a uniform float that is called that. And we can use that instead of 1 minus radius, 1 radius minus radius. And now if I change this value, you can see the area shrinks. Okay, now for that jitter, we can take advantage of this parameter we have here of passes, so we can change the amount of times our GLSL code is executed. And if we add a bunch, you can see it goes crazy because it's going in all directions. But we can change internally so that depending of how many passes we have here, the calculations get smaller. So let's add another vector here that's going to be called just dt, and that can be the inverse of the passes. So divide by 1, and now here in our GLSL, again we add a uniform float just dt, and we multiply with the sum, and it's a little better. Oh, we also need to change this to read write and copy previous pass to the output or input, but it's still wonky a bit. This is also because these circles are too big right now for their enclosure, so I can shrink them a little and reset. And but also we can add another vector here that is just like a dampening. Let's equal to 0.9, and let's also multiply our force by that amount, and remember to add it here to our uniforms. And now it should be much better. You can see it's now bouncing back instead of jittering around. Then you can change these parameters to figure out what works best for your case. Okay, so now we have this in a circle. Maybe we want to change it so that it collides in a square, and to do that here, instead of this calculation over here, let's do a different one which is kind of similar but just for a rectangle. And let's use the sine of our position multiply by the minimum of the absolute value of our position, and let's make the same way we made a bounding radius, and we're gonna make a bounding rectangle, and that minus radius. Okay, and let's create this over here. Oh, uniform. This is gonna be a vec 2 since it's a rectangle, and that's it. Now let's go back here. This doesn't work right now because we haven't initialized our vector over here. And there's another one, bounding rect, and it should be a vec2. And let's set this to 1 and 1. And you can see now, if I again increase the size, now they're bound to just a square. Now we can change the size of the square. Cool. Now also well, we can change the order here. It's a cool new thing. I think it's new. Move lock. Let's make it so we can choose between these two like modes, and that can be just another uniform bounding mode. That can be just an int. That is just either 0 or 1. Oh, that's an I. Okay. And we go in here and add that as well, uniform int. And now instead of having one of these commented out, we can just add an if bounding mode equals 0, then we do the circle calculation, and if not, we do the rectangle. Cool. Now we have it here. This is again kind of too small. I can increase the size, and I can change it between being a circle or being a rectangle. Cool. So that's our collation system. Now done. At this point, if you already knew how to make collisions in GLSL and tubs, or without GLSL at all in tubs only, you could generate those points using that, and then just using a lookup texture pop, you can get those positions into pop territory and then continue with the tutorial. Okay, so now let's also this right now the points are kind of, once the radius is set, it's kind of forever unless I reset the feedback, and you don't need it, that doesn't need to be that way. We can actually move our attribute and noise pops that are over here into our feedback loop, so that they are constantly getting updated. And that means we can actually animate the radius, the radii. There's a warning right here because this is set to warning, but we don't care about overriding the value. I'm gonna just ignore it. And now we can actually animate it. Well, actually, if I just play this right now, something maybe a little weird. Let me change this to our circle, and there's a bit of movement, but you can see it can be quite chaotic because we are using our position each time to recalculate the radius, and maybe that's a little too unpredictable. So let's set it up so it's more control. I'm gonna make a different attribute with another noise before the feedback that does use the position, but it doesn't do anything to transform anything. It just outputs the noise, and then I'm gonna call it noise seed. I'm gonna use that to seed our noise in the future, basically. So everything will go against a different value. Let's make that really low, and I can make this between 0 and 1. And now this noise, instead of using the position, it's gonna just use the noise seed. Oh, I need to actually reset the feedback one more time for the new attributes to get passed down. Now noise seed. And now you can see if I reset it, let me set the base to something a little bit lower. Now you can see the radii are set. So even though they are moving, they aren't changing. So now we can control it however we want, and we can transform it over here with our classic absolute time dot seconds. And there you go. We are changing. We can change the harmonics to make it a little bit prettier. You can increase the amplitude. And they're moving and they're pushing each other, right? I can even add a different noise that moves the positions around. And again, instead of using our position, I'm gonna use our seed attribute. I'm gonna change this, and I can also animate this one. And it's pretty. I can lower the amplitudes here so it's not as strong. And there you go. I'm gonna lower even more. Now we have also, this should be that vector instead of a scalar, I think. And down output the noise, we don't care about that. It just move around our points, and that's cool. Okay, now we're done with our collision system. We have this whole thing that outputs a bunch of points that are always separated depending on the radius of the circle they are attached to. Okay, now let's try to extrude them into tubes. So for doing that, we're going to use the trail pop that, as you can see, just creates a memory backup of every position that these points have had in the last, well, depending on how long you put it, right? Here's 1 second. Now instead of having in seconds, I'm going to change to frames, and we can use our train length parameter. And here I actually have to subtract 1 because the output of this node includes this amount of length, this amount of points, of like slices in time, plus the current one. So this is 99 plus 1. And also important here to add film missed frames. What that does is that if we're running real time and the project goes under 60 FPS or whatever your frame rate is, the pop automatically tries to interpolate between the 2 adjacent frames so that you don't skip anything. And that's important because for what we're gonna do, we need a consistent amount of points, which right now, if I later on for a little bit, we can see it's 40,000, which is exactly what we would expect since we have 20 circles of 20 divisions and for a length of 100 for a trail, right? So it's 20 times 20 times 100, which is 40,000. Cool. Now let me also we need to get that H attribute, which just tells us how long ago was this, what was each slice of time. And we can get rid of the connectivity. We don't care about that. And here we could do some transformations, right? We can change this. If we change it instead, we can start seeing kind of what we want, but it's a little annoying to work with this transformation, so I'm gonna not use that. Instead, we're gonna use the H attribute to perform and kind of weight a bunch of transformations. So first we're gonna get a normalize to normalize that H attribute, because right now it's in seconds and we actually just want a value that goes between 0 and 1. So normalize the h, which is just a float, so parameter size 1, and it's between 0 and 1. So that's good. Now, if I first transform this a little bit to the right, then I can rotate it around the y-axis with another transform, and use this weight for this weight attribute, or h. As you can see, if now I rotate, let me zoom this out. If I rotate, depending of the h of this slice, it's how far along it gets rotated. Cool. So we can choose whatever we want. I'm gonna keep it at like 300 since I like that amount, and let me just get another transform to rotate it back so that this opening is aligned to the front, to the z-axis, so it's better for the camera later. And to do that, I'm just gonna copy this parameter over here, and basically it's 360. Let me add some parentheses. 360 minus that amount divided by 2, and then I just add 90. No, I think I subtract 90 actually. Yeah, subtract 90. And there you go. And now if I change this, it's always centered. Cool. So you keep it at 270. Now what we want is we have all of these points, right? We actually want a surface around them. So we're gonna do a little trick to convert all this position information into another pop object that has the topology that we actually want. So I'm going to create a topology using a tube that should have the same divisions and length that we need, which is 20 divisions, which in this case is just the columns, and the trail length is the rows. And then we can do a copy to just have a bunch of copies of this same tube, which is the same amount of circles that we want. And now we have all of this information. This has the same amount of points, right? 40,000, and we just need to use these positions instead of this, of whatever this generated. Now I'm going to do with a math combine. We can input both of these, and we don't even have to perform any operations. We can just, instead of getting the attributes from the first one, get nothing from the first one, and from the second one we get our position. And then at the end we need to output our secondary attributes, so everything. And there it is. It looks perfect. Not really. It's all messed up, it's all janky, and that's because if we think about it, these points aren't sorted in the same way. This trail, we have a single slice of circles, so all of these points, and then the next slice of circles, and then the next slice. But for these tubes, it's just all of the points in a single tube, so all of their columns, all of the rows, and then the next tube, and then the next tube. So these aren't the same, and we need them to be the same ordering. So in order to do that, we are going to sort these points by, so that they are sorted by each individual kind of circle that they belong to. In order to do that, we can actually, inside of this copy, we have these options to get the template ID attribute, which just means just what is the ID of the point of your template you correspond to. So let's just add that to the points. We can change the name to tube ID, and just means that each circle now has a value from 0 to 20, depending on which point it was instanced on, and that gets passed along the whole thing. The reset, and then at the end here we can sort by that attribute, and then use our tube ID, and we have our tubes. There we are. Here's also, I can change the tube detail to add some end caps, and there it is. The normal's a bit weird. We can add a normal. Let me turn off those viewers. And here I don't know if this is a bug or if I just haven't correctly understood how normals work or something, but I haven't been able to manage to get like good interpolated normals so that the caps get properly weighted. So option right now is to set this to primitive so that the caps are flat, but that means the rest of the tube gets shaded according to their faces, so you get this blocky texture instead of this smooth one. So you can pick and choose, right? If you don't want end caps, if you turn this off, it doesn't matter, so you can set this to point and you have these shiny ones. What is your complete your option, and if you know how to do this so these don't get this weird interpolation, please let me know. Okay, so that's it. Now we can also add some color. We got some color here before our sort. After our sort and before our combine, we can use a lookup texture. So first, let's make our color. So you hear a noise. This is our first use of tops in the whole video today. And it's gonna be the number of circles is gonna be the X, and the trail length is gonna be the height, and we can, if we change the scale to like 1000, we get vertical lines. We can turn off the monochrome and play around with the parameters, and let me change this to nearest so I can see better. No, that's not this one. And add a null that can be just null color, and we can use here a lookup texture to look up from this top, and it's gonna output the color. You can see it's not doing anything right now because remember, here we are only getting the point, so we actually need to add the color, and there you go. And now it's all wonky and weird. Let me actually, now that we're at the classic just render setup, and a light, and let's use a font. That's a depth. Let's use a font, and I can use a transform here to add a background. And if this looks at this geo, I can raise it up a little higher. Let me change this view to like 20 and make it further away. There it is. Let's also brighten that up. Okay, so that's kind of messed up. That's not what I want. I want the colors to go along with the tubes, but instead of using this for our UV, I'm gonna use for the U, which is just which pixel along the width should you use? I'm gonna use actually our tube ID, which is just an index of which circle you correspond to. And instead of normalized, there should be a pixel index. Okay, that's looking better. And for our V, we can just use our edge because it's already normalized between 1 and 0. And there it is. We can change it to hold. Much better with hold. And now we have it. We can animate this. Then absolute time seconds. And that looks pretty cool. So that's great, right? And I remember we can change the bounding or the sizes and all that. Now that is kind of the first way of doing that conserves this flat face where you can see the collisions happening. But watch what happens over here. Let me move this around. When I try, let's say, because right now it's only kind of revolving around this one axis, right? But what if I wanted to spin around while it revolves? So to do that is very easy. Before this transform that moves it to the side, I can add another transform that is weighted by the edge and rotates on the Z axis. And you can see, whoa, it spins around. And it looks cool. It looks great. But you can see as we spin around, you start getting these weird stretches in the middle where the cross section of the tube starts being a circle and it's kind of flatter, right? And it's even more noticeable if I spin it even further. It's completely flattened. And that's because these transformations we're doing make it so that the circles are aligned with the tangents of the line they're following. So let's do something else to take care of that. So now, right now we are trailing a bunch of instant circles. Instead of doing that, we can trail points and then instant circles on those trail points. So I'm going to copy and paste this trail and plug in just the direct points, and you can see we'll let it catch up, and now it's just a bunch of lines. And then we can perform the same transformations with it. I'm gonna even just copy and paste this entire thing. Let me not select the entire thing. There you go. And as you can see, you end up with this kind of where it should be, instead of 2 it should be 7, and you end up with this bunch of lines. Actually, in this trail we can also add some connectivity rows. Once it resets, you get a bunch of lines, and now we can, because we have lines, we can instance of those lines, and we can actually get the tangent of those lines, so we can align our circles using the line metrics pump. We can get the tangent. It calculates it for us, and now we can copy. And let me get this same circle, and I'm gonna use a copy here. Copy, and there they are. Now there's a problem. We need to again use our scale. It's going to be a radius, and also our circles are all facing the same way, but now we have the tangent vector, so we can use this template rotate to vector and just use that tangent, and there they are. They're all rotated according to the line they should be following. Now, before I plug this in and just switch it, remember that this is sorting by the tube ID, and now we don't have a tube ID because before we got it when we copied the individual circle to the points. So to get that, I'm gonna just actually before even the trail, with a simple math, there's actually already an intrinsic attribute that is called just index. But it's not called that, it's point I, which just means the point index, and that means we're just gonna get the points, the original points index, and just rename that to the tube index, tube ID, and there it is. Now it gets passed along the entire thing, and right at the end it should also have each tube should have its own tube ID. So I can just plug this in into our sort, something's going on, and here is saying input attribute not found. That's because we set the tube ID to these lines, but these circles don't have that, and we are copying the circles onto the lines, so they don't have by themselves the tube ID, and we can just change that by using template attributes, and we need to use template attributes, and then just gonna copy it from the point, and it just I need the tube ID, and I'm actually also gonna need the edge, because remember we need the edge for the lookup texture. So the edge, and now it's working again, and it looks the same because it basically is. But if I unbypass this transform that spins it around, now it looks wonky. But if I decrease it a little bit, you can see that now the cross section of the tube remains a circle. And something you lose in the process is that these faces aren't flush against kind of an invisible wall that lets you see the collisions, but you know, take what you can get. I think it still looks pretty cool. Now we can just finish this by adding a switch, so we can switch between our different methods. There you go, there's one way to keep it flush. We can also decrease here the radius a little bit, and the other one, which it's easier to spin around, transform, and of course these rotations aren't the only things you can do. You can do all sorts of crazy things, right? But I think that's it for today. I hope you enjoyed it. I hope you're enjoying using the new pops. I'm having a lot of fun with them. This project file will be available on my Patreon if you want to get and check it out, and check out everything else I have on there. I have a bunch of cool files, and please, if you make something with this, let me know, send it to me or tag me or something. I love seeing what you can make, and hope this was useful. Thank you so much. Goodbye.